suddenly. That's why we don't have enough notification to give you or to send you any emails or more in putting this personal page and also this site, Facebook page. We try to share it and among the as I can. I'm so sorry and I'm happy you made it. So thank you very much. Today our speaker is very interesting. Our speaker is very two of our from that to ask them kindly to give a talk about their research center, which is important, Egyptology Society, which based in Cairo. In Egypt, in Cairo. So we've been keen to have this lecture here in Luxor. This lecture, Professor Rosalie David and Dr. Kisser in environmental biology, University of Manchester. Please welcome both of them. Thank you very much.
Well, good evening, ladies and gentlemen, and thank you very much for making this look at the library. Very happy to be here this evening at the University of Manchester, where we specialize in biomedical and scientific Egyptology. So, at the very beginning of the 20th century in Manchester, there was a famous called Dr. Margaret Murray. She's the lady in the pinafore, in the apron, in the image. And she brought together a disciplinary team of medics and scientists and Egyptologists, people who work on looking at Egyptian mummies in a scientific way. And they unpacked and autopsied two Egyptian mummies Manchester Museum collection. These are called, very recently, possible to prove with DNA in Manchester that they really are related as brothers to each other. So the results obtained from Dr. Margaret Murray really set the pattern for the kind of work that we actually do today. So the Manchester Egyptian Mummy Project started back in the 1970s. I went to the University of Manchester Museum in 1972 to look after the famous Egyptology collection there. And in 1973 we set up this project to work on the mummies in the collection. 21 human mummies and 34 animal mummies. And we've worked together, different people on the team, of course, over the years, but for 5 decades. And so it's the longest established project study of ancient diseases really anywhere in the world. Now, we have made aims on the project from the very beginning. First of all, we wanted to establish a methodology, a system of examining mummies. Until then, be aware individual mummies had been they'd been extracted and beat on. That hadn't been a total package, if you like, for examining mummified remains. And here I am many years ago in 75, my medical colleague wrapping one of the mummies in the Manchester Museum collection. Now the second aim, and which is so important today, is to use biomedical and scientific techniques to gain extra knowledge of disease, about their diet, their lifestyle, the treatments they had. Very, very fortunate in that a lady whose initials are KNH gave the university a large sum of money, which enabled us to establish a special centre for biomedical Egyptology in the university. And this was opened in December of 2003 by His Royal Highness, the Earl of Wessex. And for those of you who are not British, this is our Queen's youngest son. So it was a great honour to have him open the centre. And the Manchester Mummy Project, all the work we've done over all those years, formed the basis for what we have gone on to do in the K&H Centre. So the K&H Centre, we've got the main focus, which is this interdisciplinary approach. We combine history and scientific methodology, and we look at diseases, we look at medical treatments, lifestyle, and the funerary practices of the ancient Egyptians. And it's the only university facility in the world where Egyptology can be studied as a bioscience. So it's not in the arts subjects, it's in the medical school, and you study it as a medical scientific approach. And the teaching and the research we do are based on all those diagnostic tools that we and others have developed over the years for looking at the Egyptian civilization and the environment of that civilization which gave birth to it. So we have a lot of resources. Because we're based in the medical school, we have access to, for example, the X-raying, the CAT scanning facilities, and we've X-rayed all the mummies in the Manchester collection, and we've also X-rayed other mummies as well. They have to go in at weekends because it's thought not a good idea if you go in the week as a patient and you see the previous person coming out as a mummy. So over the years, we've gone in over the weekends. We also have our own dedicated mummy tissue bank. We collected this together some years ago, and we have over 2,000 samples of hair, bone, and tissue from Egyptian mummies outside of Egypt, but from collections around the world. And this is really important. If you're trying to do statistical work, you need enough tissue samples to make that viable. And of course, being in what is Europe's largest university, have 30,000 students, we've got all sorts of other facilities and opportunities which you'll be hearing about later in the science and medical faculties. So the Ancient Egyptian Biorepository, or the Mummy Tissue Bank, this is a unique resource. It is a bank. We not only work on the tissue and the samples ourselves, but we loan samples out to other bona fide researchers who have research programs. And we also have in our collection the Grafton Elliott Smith collection. It's a skeletal collection built up by Sir Grafton Elliott Smith, who was Professor of Anatomy in Cairo, in Manchester, and eventually at University College London. But he had this collection of skeletal remains from Egypt, and again, they're there as a basis of some of the work that we do. So just to give you a brief introduction, really, to some of the kinds of projects that we've covered in the K&H Centre over the last years. We've had various disease projects. Schistosomiasis, some years ago, Egypt and the United States had a project on schistosomiasis in the modern society. And we were asked if we would provide the context in ancient Egypt so you could study the evolution of the disease over some 7,000 years. So we linked up with the Egyptian Ministry of Health and the American setup, and we were able to show how schistosomiasis developed in antiquity as the basis to the modern work. We also, as I'll mention in a minute, we've had a project on atherosclerosis, or furring of the arteries. We've looked at cancer, and there's some really interesting results from this. And then pharmacy, a pharmacy project to see the kinds of medicines and treatments that the Egyptians used. An animal project, and then work on Grafton Elliott Smith and his archaeological survey of Nubia. So just a word about the schistosomiasis project. This was the first major epidemiological project on disease in Egypt over 5,000 years. And epidemiology, as I'm sure many of you know, means that you're looking at the evolution of a disease over a period of time. And it's really interesting because you ask, why has the disease changed? What are the different conditions in the modern world that give rise to that change? And so it does have a modern impact as well. Now, the major achievements in this project were the development of immunocytochemistry as a diagnostic tool. You can find evidence of this disease radiologically. You can look at mummies and you'll find some of the secondary stages of the parasitic infection. You can look also histologically, but you've got to actually land up on one of the parasites or the eggs in the whole body. So it's really a problem. So what we did was to develop immunocytochemistry. And this shows by fluorescing green if the person had that disease in antiquity. It's a sort of litmus test as to whether it was present. And it was also possible to make the first identification of parasite DNA. We found one of these parasites in one of the mummies, so 2,000 years old, and it was possible to get the DNA out of the schistosome. And we wanted to see if the DNA of the schistosome had changed over 2,000 years from then until modern day. It hadn't, but it's an interesting experiment to see what the situation was. Now, atherosclerosis, as many of you know, is what we all think of as a modern disease. You eat the wrong diet, you have the wrong fats, and you end up with this degenerative disease of the blood vessels. And as you know, it's widespread in modern industrialized societies. It's linked to diets high in cholesterol and saturated fats. But it has been found in lots of Egyptian mummies, especially those belonging to priests and their families, by our own researchers, but by other researchers elsewhere. And some years ago, I was at a dinner at the university in Manchester, and I was sitting next to the professor of cardiology, and we talked about what we did. And I mentioned this, and he became very interested and said, if I could send across the menu that these people ate, they would look at it and see whether it would, in fact, induce atherosclerosis. Now, as many of you know, the priests ate the food that came from the altar of the gods in the temples every day. So the menu of that food is written up on the temple walls. So I did a translation of the hieroglyphs and sent it to the professor of cardiology, and they looked at this. So most people in Egypt ate bread, fish, fruit, and vegetables, a very healthy diet. And this disease does not occur generally in the bodies of the non-elite population. The priests, of course, were on a different diet. Beef dinners every day, wine, beer, fatty foods, bread and cakes, and so it was a disaster. And my medical colleagues came back and said, wow, it's a dreadful diet. And so we could show that the diet was linked to this particular disease. So the Manchester analysis of the dietary content of the foodstuffs that the priest ate supports the theory that this is a diet-related condition, which had been disputed in modern times until then. But we published it in The Lancet, which is the well-known medical journal, to show that the ancient Egyptian evidence actually proved what was happening with a modern disease. Now, cancer is another very interesting disease. If you study the history of cancer, you can essentially improve the understanding of how to prevent the disease, the pathogenesis of it, and even the treatment. Now, there's a scarcity of malignancies in ancient remains, and it's led people to question why. What is the role of carcinogenic factors like smoking and diet and pollution in modern societies? Some people have said, well, it was rare in antiquity because they didn't live long enough to get it, or that we have inadequate detection techniques. But all the evidence shows that the Egyptians lived long enough to get other diseases of older age. There's very little evidence of childhood or young person's cancer in ancient Egypt, and so you can't fall back on those arguments. In ancient societies lacking surgical intervention, you should have evidence of cancer if it's there in all the preserved specimens. So despite these problems, we came to the conclusion that it probably was due to the absence of carcinogenic factors, such as the use of tobacco or pollution from industrialization, that was the reason why they had far less cancer. And we published this, it was quite a controversial article in Nature Reviews Cancer. So I'm going to talk just very briefly about two of the early techniques that we used, and then Dr. White will continue with some of the techniques that we are embarking on and using today. The first one is radiology, of course. You get all the evidence from the skeleton and any of the remaining soft tissues. And the other one is histology, looking at tissue samples under the light or the electron microscope. So radiology, Flinders Petrie, the famous archaeologist, he was a great thinker outside the boxes, and he probably was the first person to obtain the first X-ray of a human mummy in 1897, soon after X-rays had been discovered for use on modern patients. But the scientific value of these was not really recognized or investigated until the 1960s, when there were some general radiological surveys. But what Manchester did was to establish a methodology. The mummies were all taken to hospital, so instead of being examined on the museum gallery or at the archaeological site with portable equipment, they went to state-of-the-art hospital environment. And we used fluoroscopy and tomography, and later, of course, added CT scanning. So you can tell, you can determine disease in the skeleton, in the remaining soft tissues. You can get information about the mummification and the funerary customs. And of course, a spin-off of this is that you can look at the dentitions of the mummies. Either if they're dry skulls, they can be examined just by hand, but if you need to look at the X-rays, then you can get evidence of the teeth, the dentitions, from the radiographs and the CAT scans. Histology is the first step you should do to look at mummified tissue. And paleohistology, as it's sometimes called, this technique was developed by Professor Ruffer, who was professor of bacteriology in Cairo in the early 20th century. And he developed this technique. Now, you have to rehydrate the mummy tissue, which is dried out, of course, by the mummification process. And people use different techniques for this, water or alcohol, or one very effective treatment is to use fabric conditioner, because this will make it a very good result. And there's a learned paper some years ago was published called How to Comfort Your Mummy. Comfort being a fabric conditioner we have in Britain. To get these tissue samples for histology and for DNA and other techniques, you need uncontaminated tissue. So we developed endoscopy, which is a means of inserting, we use an industrial endoscope into the mummy through one of the existing holes in the body and taking samples from deep inside the mummy. So you should always use radiology and histology as your first approach, but then go on to these other techniques which are really the current state of the art, as you'll hear. Now, on the Schistosomiasis Project, we found that 70% of the samples we looked at were positive for schistosomiasis or bilharzia. Now, as you know, probably this is a very debilitating disease if it's left untreated. And so what was going on? Were the ancient Egyptians treating this disease? Because the Egyptians were not debilitated. They were building temples and pyramids and a wonderful civilization. So we had a grant for 3 years to look at the pharmacy in ancient Egypt. And we combined this Manchester methodology of history and science, and we looked at the pharmaceutical prescriptions which are in those 12 medical papyri that have survived from ancient Egypt. We also looked to see if we could identify any of the traces of these treatments in the mummy tissue. And then we wanted to see how accurate these treatments were. Did they really work? And then to analyze some of the products in the medicines to see whether they'd been imported into Egypt from other areas. So we linked up. Here you can see the late Professor Mohammed Demirdash. He had a center in Sinai looking at Bedouin medicine. And this, in a way, is a link between ancient Egyptian and modern medicine. So we worked closely with them. But these were the amazing results. The Egyptians practiced a credible and reproducible pharmacy 1,800 years before the Greeks. Now, people always go on about the Greeks and how they developed pharmacy, how they invented it. No, the ancient Egyptians were there 1,800 years before with viable, reproducible treatments. 64% of those remedies that we get in the Egyptian medical papyri are effective today. So they work, they're not magic. Most of them are workable treatments. And 50% of those drug sources are still used today in medicine, many of them synthesized into medicine. And we showed also that some of the resins and unguents from the early Egyptian tombs, which were later used in pharmacy, had come from contact at an early date between Egypt and other parts of the Near East. So that's pharmacy. Grafton Elliott Smith, here he is in his time in Manchester. Those are his dates. Best known, of course, for his study of the royal mummies here in Cairo. But in fact, his most significant contribution was to develop this paleopathological tradition, the study of disease in bodies. And much of this was based on his role in the archaeological survey of Nubia. So he was invited to go as the anthropological advisor to the ASN in 1907. This had to be done, of course, because with the building of the first dam at Aswan, a lot of the bodies in the surrounding areas were going to be destroyed. So they exhumed and examined 20,000 human remains and animal remains. Imagine 20,000 individual bodies. And he pioneered this modern epidemiological approach where you look at disease patterns over the millennia in both Egypt and in Nubia. And he produced very systematic studies. So the Manchester Project set up a dedicated website where we showed where all the material from the ASN had gone. We checked all his disease diagnoses, and then the new studies that have been done on these diseases were added in. And this work is still ongoing. We did have exhibitions and day schools, and there are publications, but it's still an ongoing work. Currently, we're involved in a new mummy study, soon in the next few weeks, in fact. This is the mummy of a lady called Takabuti, who lived here in Thebes in the 25th dynasty. She has been for many years, since the 1850s, in the Ulster Museum in Belfast in Northern Ireland. So 10 years ago, we were asked to go and investigate this mummy, and there are some very interesting results. some techniques, GCMS, showed that the hair of this mummy was Caucasian. So she is from, we think, outside of Egypt, maybe come in and married and living in Thebes. And some of the studies we undertake in the next few months will in fact try to show who she was, where she was from, what her diet was, what her diseases were, a whole picture of this individual. So why study biomedical Egyptology? Well, Egypt has, as I'm sure everyone in this room knows, unique conditions. You've got continuous history of the same people in one location over 7,000 years. So you can look at the development and the evolution of disease over that period. You've also got, from antiquity, the preserved bodies of all social groups, from the royal mummies through to the ordinary people of ancient Egypt. You've also got the skeletons and the tissue. So you not only can x-ray the mummies, but you can look at the tissue samples with a range of biomedical techniques. And then you've got the literature, those medical documents, albeit there are only 12 of them in known existence. They give the evidence of the diagnosis and the treatment. And as we've shown, the pharmacy treatments were for the most part not magic. They were proper pharmaceutical treatments. And then you've got this unparalleled opportunity in Egypt to look at the development of the history of disease and pharmacy, not just for Egypt, but indeed for the whole world. So the future of biomedical Egyptology, this provides the evidence that is often missing from other sources. As you know, the archaeological evidence of treatment, you've got the sanatorium at Dendra, but the other evidence is not really there. You've got the art or the iconographic evidence in the tomb scenes. The elite are shown as perfect, young, beautiful, with no disease at all. It's only if you look at the servants that you sometimes see evidence of disease. So that's skewed information. And then inscriptional sources, 12 medical documents have survived, are known from 3,000 years of history. But mummies are the answer because they are a museum of disease. If you get the right techniques and you look at the mummies in the right way, the evidence is there thousands of years later. So it adds a significant new dimension to the study of Egyptology. You've got the language, you've got the archaeology, the history, the art, but also you have the biomedical studies. And it's a unique situation in the world. So our location, the K&H Centre, is in the medical school, and quite interestingly, this last year, for the first time, students studying medicine in Manchester, who are going on to be doctors, have had the opportunity and taken it up to do a course on the history of ancient Egyptian medicine. So they'll go out into the world with a knowledge of where all the medicine actually started. And we've got this frontline medical technologies. It's a modern platform, as you'll hear in a minute, for all the studies on ancient tissues. It's a really exciting opportunity for the next 20, 30 years. So I'd just like to thank the following for supporting our work. Our patroness, K&H, she has supported our work from the very beginning. We've had grants from the Wellcome Trust, the Leverhulme Trust, and the British Academy and the British Council. So it's been very supported by these funds. We will next year, in September, embark on an online degree, a Master of Science degree in biomedical Egyptology. So this will be able to go around the world. If you come from an archaeology background or a science background, you will be able to study, and then hopefully there will be summer schools in Manchester and also perhaps in Egypt. So if you watch our website, over the next year you'll see this facility available, hopefully, for the future. So I'll now hand over to my colleague, Dr. White, who will talk about some of the really high-tech things that are happening at the moment with the project. Thank you very much.
I don't know whether I
Try to...
does it work? If not, I can shout. I'm sure I can speak loud enough, actually. Honest, I'll not to use that, sticking. So if you... But no, if I'm finding it noisy, I'll use it then. Assuming it works.
Working? Work. Yeah.
So it is working, I can hear. Right. So very brief in terms of myself. Yeah, it shows how Egypt has such an attraction because my background is in environmental science, environmental biology, also environmental, which is the Professor David mentioned, and new approaches to mummies. So it's all mummies,